Good afternoon. Our topic for today is population growth. Okay. If you say population growth, your P now is dependent on the following variable. We have your P sub O, multiply it with your Euler's number raised to R times T. To define out the variables, we have the following. P now is the total population after time T. P sub O, it is the starting population. Your R now is the percent rate of growth. Your T here is time in hours or years. And then your E is your Euler numbers. To manipulate the formula, solving for time T now is equal to the natural logarithm of your population at any time T all over the original population value all over the rate. Solving for your population growth rate, we have R is equal to the natural logarithm of your P all over P sub O all over your T. Given two time in years values, we have your delta T is equal to T sub 2 minus T sub 1, or your um, time in the future minus time in the past. And then your delta T could be equated to the natural logarithm of your P all over P sub O all over the rate. Okay. Again, your ln stands for natural logarithm, and then delta T stands for your delta or change in values from final to initial. We have your first sample problem. The exponential growth model, P is equal to 30,000, your Euler's number raised to 0.02 times delta time, describes the population of a city in the Philippines in thousands. C is time in years after 1995. Okay. We have the following sub-question for this problem. What will be the population in 2017? What will be the population in 2025? To solve now this problem, okay, solving for your letter A, to determine the population in 2017, we have the following given values as your original population. It is equal to 30,000. And then your rate at 0.02. This is not in percentage, but it is in fraction. And then your time in the future, or your T sub 2, that is your year 2017, and then your initial time as 1995. So we are required to determine the number of population at year 2017. To solve this one, we have to substitute the following values as P is equal to 30,000 times your Euler number raised to 0.02, multiply it with the change in time, okay? So 30,000 times Euler's number raised to 0.02, multiply it with 2025 minus 1995, gives us almost 55,000 people, okay? We have your second sample problem. The exponential growth model, P is equal to P sub O times your Euler's number raised to the rate times your delta time. For letter A, we are given with P is equal to 786,000, your P sub O or original population value as 247,000, and then time as 17 years. So we're going to solve for the rate, and then for letter B, we are given with 1.68 million, and then the rate as 12% per year, and then the time, which is 8 years. So we're going to solve for the original population or PO for B. Okay. For letter A now, the solution proceeds as the given values. Okay, we have your P as 786,000, your P sub O as 247,000, and then your time as 17 years. To determine now your rate, we have this formula. Your rate is equal to the natural logarithm of P all over P sub O quantity divided it with T. Okay, substituting the values, we have your natural logarithm of 786,000 all over 247,000 all over 17 years gives us a rate in fraction 0.0681 per year, or if you're going to convert that in percentage, that is 6.81% per year. And then for letter B, we are given with the following values as 1.68 million, your rate at 12% per year, and then your time in 8 years. To determine now the original population, 101,680,000 all over your Euler's constant number raised to 0.12. Okay, again, the rate must be converted into fractions, so it becomes 0.12, and then multiply it with your time, gives us your answer 643,261 people. Okay, so that concludes my presentation for population growth. Hope you enjoyed it.